My name is Professor Subhash Anand, and I'm Professor of Technical Textiles at the University of Bolton, England. And my main areas of research are healthcare and medical devices, personal protective equipment, and other technical textiles. This innovative research and development project has been completed at the University of Bolton in collaboration with Boltex Limited, Ilkeston, Derbyshire, and Mr. Brian McArdle from Warrington, Cheshire. Pressure sores, also known as decubitus ulcers, pressure sores or bed sores, are a type of injury that breaks down the skin and underlying tissue. They are caused when an area of skin is placed under pressure. The severity of pressure ulcers can vary from grade 1 to grade 4. A grade 4 pressure ulcer is the most severe type of ulcer in which the skin is severely damaged and the surrounding tissue begins to die, tissue necrosis. The underlying muscles or bones may also be damaged. Pressure ulcers can develop when a large amount of pressure is applied to an area of skin over a short period of time, or when less pressure is applied over a longer period of time. This extra pressure disturbs the flow of blood through the skin. Without a blood supply, the affected skin becomes starved of oxygen and nutrients and begins to break down, leading to an ulcer formation. Pressure ulcers tend to affect people with health conditions that make it difficult to move, especially those confined to lying in bed or sitting for prolonged periods of time. Pressure or decubitus ulcers are considered to be one of the major diseases and cost the NHS in the UK between 1.8 and 2.6 billion pounds per year. Polyurethane foam is commonly used for seating and cushions in many applications, varying from car seats, chairs, wheelchairs, sofas, mattresses, and furniture. It is well known that polyurethane foam cushions and seats are not breathable and lack thermophysiological comfort. They're also not washable at high temperatures and are environmentally hazardous, both in terms of flammability and recycling. Warp knitted spacer fabrics are extremely versatile in terms of designing, thickness, comfort, washability, compression, and resilience, and above all, they are extremely efficient in pressure relief. These unique three-dimensional structures can have between 2 mm and 60 mm thickness with good compression, resilience, and breathability. The two independent fabric faces can be knitted into any kind of mesh or solid structures, and in order to sustain the space between the two faces and to obtain the required compression and resilience properties in the thickness direction, monofilament yarns are normally used as the spacer yarn. These structures are also isotropic and hence are more conformable to the different shapes and sizes of the body. A systematic research and development project was carried out on the design, development, and characterization of pressure relieving cushions by combining a series of three-dimensional warp knitted spacer structures in order to achieve the desirable properties such as good compression resistance and resilience, reduction of peak pressure, and pressure distribution over much larger area of the cushion. The pressure mapping trials confirmed that the maximum pressure, average pressure, as well as the variation of pressure within the entire area of the cushion experienced by the wheelchair patient will be well over 50% lower than that endured by the patient when sitting on the same wheelchair without the support of the aerospring cushions, AS200. The fundamental research work was carried out at the University of Bolton, UK. The aerospring, which are now a trade brand, which is a brand name, the aerospring cushions have been covered by a patent application and are being commercially developed and marketed by Boltex Limited, Ilkeston, Derbyshire, UK. The various innovative and unique features of the aerospring cushions are as follows. They are much better at reducing peak pressure under the bottom than polyurethane foam cushions. They distribute the pressure evenly over much larger areas of cushions or seats than polyurethane foam cushions. They conform to the shape of the body and have sufficient compression resistance support the person without bottoming out. They provide a well-ventilated, comfortable surface that does not unduly restrict movement. They can be laundered in the washing machine, are non-flammable, and can be easily recycled. They are particularly beneficial to the persons who are prone to developing pressure sores due to prolonged periods of sitting in the wheelchair or other support systems. Following the successful completion of this project, the Technology Strategy Board, through the recommendation of Knowledge Transfer Network, has awarded Boltex Limited a total grant of £511,000 in order to further develop the pressure relieving devices in new and novel areas of application. A new 3-year research and development program has been initiated jointly by Boltex and the University of Bolton at the University of Bolton.